begin with the ModBus, which we are very excited about, and then we're going to move to DiversaFlame. Just as a reminder, if you could all mute your phones, we do get a lot of feedback, so we just want to make sure everything goes as smoothly as possible. If you could also save your questions for the end. In that little box for the GoToWebinar, there should be a little spot where you can actually type your questions in. So if you want to go ahead and do that, we'll get to those at the end of the presentation. Here with me, I'm Nicole LeBlanc, the Communications Manager. We have Mark Orzak, Product Engineer for the ModBus, Justin Jenny, Product Engineer for the DiversaFlame, Dave Davis, Product Engineer, Todd Romig, VP of Sales and Marketing. So here I'm going to turn it over to Dave Davis, who's going to start about the ModBus.
Good morning, gentlemen. Can everybody hear me good? Yes, Dave. Good. Make sure that those phones are on mute, please, because it'll be tough to communicate if the phones we get some background noise. First, we're going to be covering two subjects here. One, our new ModBus interface adapter that Mark's been working real hard on. We're going to be introducing that product today. The availability of the product, we will have it as of September 1. There's some important facts that we'll go over in the PowerPoint about the interface. And then the second half of the webinar, we're going to be going over the DiversaFlame, which is a brand new product we got coming out. The production on that is actually going to be, we'll have product in inventory. We're running them now, so we will have product available right away. So the first subject I want to go over is the ModBus interface adapter. General introduction. What we're going to do is go over general introduction, some specifications, some functionality, and a description of monitoring and the control itself. ModBus, just for those, the definition, it's basically a data communication bus in use for many years in the area of industrial, building, and control systems. Originally developed in the 70s to facilitate communication between programmable logic, controllers, PLCs, and industrial machinery. Very popular due to its familiarity and ease of deployment. The capabilities. As we know in the heating business, especially in commercial, a lot of people want to be able to read information of what their systems are doing and actually interact with the equipment. So the capabilities of this ModBus will allow devices with different functions and capabilities to communicate on one bus. Devices on one bus can be from different manufacturers and can communicate seamlessly with each other. Each bus has one master device and up to 127 slave devices. Master devices sends data to the slaves and ask for data from the slaves. Slave devices respond to requests from master and implements commands from the master. Wow. Easily converted to BACnet or LonWorks with external converters if necessary. This gives you a little picture of the box with the cover off. The cover will have our logo on it. We pre-wire it, have the connection cable, which has at the very end, it's a little difficult to see, but that's the same cable connection that we use to connect up to the 926 control. So that's where your connection would go from the ModBus adapter to your 926 on your appliance. And then we have a power cord with basically a power cord, which basically powers up the ModBus adapter. Here we're looking into the box and looking at the board a little bit more. Starting from the left going down, there's three LEDs that we want to bring to your attention. There's an LED for communication, showing that you're getting communication from the 926. There's data to the ModBus master, and then there's data from the ModBus master. So these lights will flicker on and off. They are different colors, and they do represent active communication to a BMS system when you connect it up in a commercial installation. We have a built-in termination resistor. We have a ModBus connection. You can see that. That connector is a 3-wire connector, which we'll explain a little bit more as we go along. And then what we did is we put strain reliefs in there for just ease of facilitating wire connection for the customer. Oh, one thing, can you go back one slide? One thing I do want to show everybody, in this section here, there is an area which we don't use on the board that looks like for toggle switches. That was not, that's just
not implemented for our requirement.
Okay. So there's really no toggles in this area. So if anybody ever asks you that question, looks like a toggle switch in some of the drawings. It's just hard to draw, but it's not populated at all. You can see here the LED labels for the on the board. We have a D7, which is an internal faults. We have D6, data transmission, and D5, data received. So those are those LEDs just explained. This just gives you a typical ModBus installation, and later on in the PowerPoint, we'll show you 3 different ways you can wire up multiple boilers to a BMS system. There is different ways to connect up the ModBus adapter to give you more information on each boiler by having ModBus adapters on each individual boiler, or you can just have a ModBus adapter on the master and see limited information on the connected followers. So you can see there's 3-wire connection. You have an A, you have a B, and you have a ground. And those will be connected to the ModBus adapter. There's a jumper that needs to be removed. Continuing on, the ModBus adapter issues concerning HTP products. One of the main things is that you have to know right up front is that the this ModBus adapter is sensitive to the 926 control that we have on the main appliance. So it'll only work on 926 controls with a software revision or a label that's labeled on the transformer of MPSA 110414 or later. Now, we have anticipated this being a problem. We've already executed, and on the front of the cover, we're going to not only tell you the date and by the product categories what appliances will have this new control software revision. So to give you an example, on the front cover, we put a little note right on the front cover of the installation instructions for use with ModCon, ModCon VWH, Pioneer, VersaFlame, Mac, manufactured on or after July 1st. For use with Elite and Elite VWH, manufactured on or after August 1st, 2011. And starting July 1st, all parts, all 926s will have this software. Plus, within the manual, we reinforce to the contractor to look at the controller. We know we are going to have issues from time to time, but we're trying to communicate this as best as possible. Connections to programming of the port of the 926 requires a 120-volt power source as well. Some of the basic requirements for programming, there's basically 4 steps. So within the appliance, there is programming, and when you're programming your parameters, you need to turn the ModBus on function 37, on function 38, the work address, function 39, the baud rate, and there'll be, how many baud rates are there, guys? 2. There's 2 different baud rates. It'll be selected by the guy who's implementing the building management system, and we'll know what baud rate we should have. And then the stop bits are parity, which is function 40. So when you're programming, just like you're doing an outdoor reset or changing an outdoor reset, these 4 parameters need to be adjusted within the appliance programming function in order to activate the ModBus adapter to the building management system. Technical description, physical layer, serial communication, ModBus, ASCII 2, verbose in structure, not most popular implementation, ModBus RTU, more compact data structure, most popular and efficient to use on HTP ModBus adapters. I'd ask the engineers to kind of explain that because that just went right over my head, and I'd like to understand it a little bit better in layman terms.
How are you? Different ways to frame the data that's transmitted and received over. One is called ModBus ASCII and one is called ModBus RTU. By far the popular method in use is ModBus RTU because you can send less data to transmit the same information. So it's more efficient use of the communications, and that's the one we use in our product.
Okay.
In ModBus ASCII, you have to send more digital data over the bus to transmit the same information. So
Okay.
It's not as popular.
So there's like more overhead in the communications.
Right.
Okay.
All right, thank you.
Guys, real quick, we're still getting some feedback from some people who haven't muted their lines. Please take a moment to do that because we can hear you, which means everyone can hear you.
All right, continuing, the ModBus in a world of boilers and building management systems. BMS is the master on the ModBus. Boiler and other devices are slaves. Other devices, including flow meters, pumps, valves, and other. HTP's ModBus adapter can control, monitor, or control and monitor boilers and or devices. HTP ModBus adapter has more capability than the competitors. Can one of the engineers comment on that? We evaluated some of the competitors' ModBus capabilities, and there were some things that we pointed out in the meeting yesterday that we felt were prudent. What are those?
The big thing is that the competition's ModBus adapter doesn't have any visibility of data from cascaded boilers. So on the competition, if you want data from cascaded boilers, you have to have a ModBus adapter on each boiler. Whereas on our product, one ModBus adapter will give you, on cascaded boilers, bit of information back from each of the follower boilers, as well as full information from the master boiler.
Okay. Thanks, Steve. BMS monitoring of HTP product. What is available on the bus for the building management system to monitor? Some of the basic examples are temperatures, the boiler temperature, supply and return, DHW temperature, outdoor, system loop temperature. Some of the faults, you can look at your current lockout or blocking codes of what's happening with the connected boilers. Some of the history can be also relayed over the bus. Pump and thermostat status can be also viewed, and user settings can also be monitored. BMS control, what do we make available on the bus for the BMS to control? Boiler enabled, so in other words, we can turn the boiler on, heating or DHW demand, cascade or single boiler temperature settings, system sensor data, DHW sensor data, cascade or single boiler power command, so we can command the power, what our modulating rate would be to the fan on the boilers. Outdoor sensor data can also be controlled. This just gives you a little bit better idea of three ways in a multiple circuit installation where you have cascaded boilers. There's four represented here. You can see the building management systems. But the first one illustrates in option A, it says ModBus Cascade, control lease and monitoring lease. And what we mean by that is the building management system connected to the master boiler in a standard cascade system. Detailed data is available on the building management system from the master, as you can see here. You got that direct connection from the master, but only limited to data available from the followers. So the master boiler is basically controlling through our boiler program what the followers are doing, and the building management system is monitoring what that's doing. And it's got limited availability of information on each connected follower boiler. So this, as far as our discussions yesterday, is probably the least limited in a cascade installation amount of information you can acquire for the bank of equipment tied to a building management system.
Right, that's right.
The building management system on the second example here, which is option B, we can control least, where monitoring is good. In other words, we can monitor all the connected boilers, but we're actually controlling, the control is coming from our controller. All the building management system doing is really monitoring what each connected boiler is doing as far as its individual faults and as far as what its individual fan speeds might be, what its supply and return rate is, what its firing rate is. So the detailed data is available from the master and the followers, but ModBus only controls master. So our control is controlling these bank of boilers based on our standard product cascade programming, and then the building management system is taking and getting more information than what we saw up here because we've got ModBus adapters on each one. And then the final one, which is ModBus Cascade, option C, control is the most and monitoring is the most. So what you're doing here is the HTP ModBus adapter provides detailed data and controls each boiler in the cascade. So in other words, what's happening is the ModBus in this example is controlled from the building management system, and then the adapters can read information based on what the customer's needs are and what they want to control.
Right, and that third scenario there, the BMS actually controls the cascading of the individual boilers.
Okay. Questions at this time? Yeah. Why don't we do questions? Why don't we do questions on the ModBus while we got the engineers here? Could you please, if you have any questions, could you submit them now on the ModBus?
David, you want them written or verbal?
What do you want to do?
We have written's easiest.
Written would be the best way to do it, Ken.
Okay,
appreciate that. Shipping date. Shipping date on ModBus, we're September 1st is when we will have.
Something first.
We have to expand that. I can't read it.
I will do that. Okay.
Or do you would? Ken writes, why would you do version B over C? And there's really no reason. You could do either or.
Yeah, there's a good reason.
Oh, there is?
It depends on the capabilities of the building management system.
Okay.
If the building management system is a relatively simple building management system that can only monitor and doesn't have good control, then you would do option B where you use the 926 to cascade the boilers.
Okay.
If the building management system is fully capable and able to control the cascade of all the boilers, then yes, option B is the way to go.
I know you got like that.
And the building management change the set points if needed.
That depends on the building management system.
But it can do that.
The set points are available as registered on the ModBus adapter, so they are accessible by the master, whatever that happens. You know, if the building management system has the capability to do that, then yes.
And Ken writes, it seems like C, there's less wiring.
This is true.
Okay.
Yeah, you don't have the Cat5 connections between our 926 controllers.
And then Brian writes, will the ModBus affect the boiler warranty if the BMS assumes full control? There should be no impact at all because the boiler limits, Brian, are still intact. So in other words, all of our safeties are not affected by the customer changing individual parameters.
Pardon me? Not at all. Not at all. I don't know what
It's a boiler control. Eight. Yeah.
Oh, yeah. We're going to see when the various units compatible, i.e. EL299.
They can only bring the boilers on and off versus let the boilers.
On all Elite products, it will be August 1st of 2011. And the ModCon VWH Pioneer and VersaFlame is July 1st. And that'll be right on the front cover of the installation manual. We'll also put it in a tech notice so everybody knows that. Will HTP supply ModBus to BACnet or LawnWorks adapter cards? I would assume.
I don't think we've ever actually talked about whether we would supply them. They are readily available from a number of suppliers.
So if they do need to get an adapter or a link that is readily available to communicate with the ModBus through those two. Okay.
So those devices are readily available on the market. We could certainly recommend some at this point.
Okay.
Whatever you get. If there's a big enough interest, I guess we could consider more up to Todd and the guys then.
So right now, no, we won't, but if we get enough feedback, please contact your regional manager, and then we'll bring it.
Okay. And it says, we already had talked about that. Will you have some detailed written information we can review? I have some applications, any online video being produced. Right now, we do have the manual and the brochure we're working on. A video is something that Todd's telling me that we are going to work on. I don't know what that timetable is, but I would assume, would it be within 30 days? Okay. So we will have something in 30 days video for the ModBus, and we'll try to get as much information utilizing our online servicing as possible. Doug asked, will the BMS system change operation efficiencies of the boiler? No, it should not affect it. If the building management system is controlling the temperatures, depending what those temperatures are, we see them either decrease or increase in temperatures being fed to the boiler, which will affect its operation, but from control to control, it shouldn't make a big difference. Okay. I think we've answered all the questions on the ModBus adapter, and I think we'll continue now on the VersaFlame. Okay, the VersaFlame. VersaFlame, we're going to go over the general introduction, marketing materials, specifications, functional description, and cleaning. Again, make sure those phones are on mute during while we talk so we just don't get any feedback. Nicole, why don't you go over this?
Okay. So as far as sales collateral goes, you all should have received your binders. Within those binders, we have the white papers, the submittal sheets, warranty. There are two brochures, the VersaFlame brochure, and then we did create a very nice Versa Series brochure. So that's going to help you explain a lot of the differences between both the Versa Hydro and the VersaFlame to your customers. Then Tony did also create a VersaFlame banner, which is also available, and you should have received two of those per launch kit that you received.
Okay. Thanks, Nicole. And the website?
Yep, on the website, there is a section for the combined heating and hot water, so there's the new VersaFlame up there. The video, which all of you have given us great feedback on so far, we have that on there as well, along with all of the brochures, manuals, warranties, specifications, and submittals. Everything's completely updated and on there for you.
So we do have a VersaFlame video of the operational system. Oh, great. Okay, good. Well, I got to keep it. Good.
You're in it.
Oh, I'm in it. Okay. Oh. All right, guys, we're going to get into some of the features and benefits of the VersaFlame. The VersaFlame, as most of you know, is a combination system where we provide heat and hot water with one appliance. One of the major features of this product, which is essentially an offshoot of the Pioneer, is its thermal mass. We have a large thermal mass on the heating side, which eliminates a lot of problems associated with short cycling, eliminates primary, secondary pumping, makes the installation really, really easy for the guys who've had a lot of customers installing Pioneer. On the DHW side, what it does is it eliminates any cold sandwiching relating to what you would normally hear in the tankless market. Because we have storage and we have a mass of storage heated in a well-insulated vessel, as soon as we start turning on the circulator to flow through the brazed plate heat exchanger, we instantaneously produce large volumes of hot water. So that gives us the ability to do a couple of things. Number one, when you draw very low draws through the brazed plate for domestic hot water, you're not going to short cycle the device because we have a thermal mass we're drawing from. It also gives you a very high peak draw capability to fill tubs and other large demand areas for domestic hot water that normal combination systems that have low mass on both the brazed plate side and also on the heat exchanger have a lot of problems keeping up. The instantaneous heat, we have a 55-gallon storage tank that I was telling you. We can get about 4.8 gallons per minute constant at a 77-degree rise. One of the things you'll notice is that we do have that peak draw, which gives us a good 5-minute production. We can go as high as 6 to 7 gallons a minute. But this is more on a continuous draw test that we did. The control interface, the VersaFlame's entire combustion system and controls can be accessed from the front with very simple and easy service wiring. The VersaFlame is easy to set up for both domestic hot water and space heating. One of the things I want to point out, which we'll go over the diagram of the appliance, is the control is the same as what we're using on all of our appliances. The fan, the system setup is all the same. Basically, it's the same as the Pioneer. We're just putting the DHW pack on the top. Space heating features and benefits, some of them I talked about. You don't have to do primary, secondary. This is a great retrofit product. It's a simple product to install. All the contractor really has to do is connect his supply to his heating, his return and supply to his domestic, and do his venting and his gas piping and run his condensate lines, and he's all done. We have up to 5 to 1 turn down ratio like we have in the Pioneer. And the heat exchanger is the same as what we have in the Pioneer, the hybrid Cooper-Nickel with stainless steel heat exchanger combustion system that we all know about in our water heaters and in our Pioneer appliances. Just to give you the VersaFlame versus the Versa Hydro to kind of make the distinction, as you go down, there's a couple areas that I want to point out. In the Versa Hydro, you can see our temperature limitation on the heating circuit is 160, where with the VersaFlame, it's made to go into retrofit. It's made to go into dirty systems, cast iron systems, 180 degrees temperature for standard baseboard for retrofit, and it operates at those high temperatures. And then this just gives you a list of what the differences are and some of the operating characteristics of the system. VersaFlame versus the competition. And you've got the Flame here, you've got the Prestige Excellence, the Naveen Combi, the Renai, Baxi, Embassy, Trinity, and Viessmann. And as we go along, we're talking about as far as hydraulic piping, what they have to do, as far as the mass of the system, eliminating buffer tanks, as far as pressure drop. I mean, we have no pressure drop because we're circulating through a large storage tank versus, as we well know, these low mass systems that require primary, secondary piping. And the DHW flow rate. Now, these are continuous draws, as you can see. We actually have a peak draw, which we're not showing here, that'll give us, for a 5 to 6 minute period, a larger amount of hot water when we have to fill a bathtub or some other larger device within the home. And then we have our first hour rating. You can see 288 gallons per hour versus some of our competitors. See that we have a very, very high rating. And then here's the different inputs. We have the 3 different models we're supplying because we're doing both jobs. We have a PHR 130-55, a 160-55, and a 199-55. We were very apprehensive of getting down in these low rates because of how this product would be misapplied and how we might have some problems in some installations. We felt that 130 was pretty much the minimum we would like to see in a majority of the jobs. That could change if we see a market demand for that. This gives you that flow chart. This is a nice flow chart to use. This tells you, you can see here we have a red line, a yellow line, and a blue line. And what we're doing is we're showing you by raising the tank temperature minimum, or the minimum tank temperature, we can actually produce more domestic hot water. And you can see this area here, which I was talking about. And that area gives you you can see at 180 degrees, we can give you a very high peak draw, and we don't start flattening out until we're up to about 6 to 7 minutes of draw. So that gives you a lot of power for quite a bit of time, where a tankless is a straight line number. And it will fluctuate based on pressures, and it will fluctuate based on temperatures. So we have a real advantage here in the operation of this system. And some of the beta sites we did, I could see significant draw capabilities of this device as I turn faucets on and off and tried them in the living space. And then this gives you the model number, the range, the tank size, gives you the gallon capacity, a 77-degree rise to kind of give you a comparison on a continuous draw. This gives you the first hour rating, and then this gives you just the dimensions.
If you're happy with what you are, you're doing well.
What we did on the manual, I want to point out a couple of things that are important. What we decided is on the manual, we decided to have one manual for the Pioneer and one manual for the VersaFlame. And these manuals now have model numbers, which are representative in the front cover to tell you what the manual is referencing. And the same thing on the VersaFlame. So you can see our three models there. And this is an illustration of the product itself. Just to kind of go over some of the drawings, just to show you the piping drawings. This is the domestic piping on the VersaFlame, because the piping of the VersaFlame on the hydronic side for both the Flame and the Pioneer are the same. And you can see here we're coming in with our cold, with our check, we're going in, and then we're coming out. We're showing here a recirc line. Once this recirc line and the pump is active, it'll activate our flow switch. The tank buffer will basically allow the heat exchanger. There's a mixing valve inside of here, and what that'll do is maintain that loop temperature for the customer as long as this pump is running. And then as the tank temperature drops, like any recirculation loop that you would have in a home, except we're doing secondary heat transfer, the unit will fire once it goes below its differential set point. We changed the wiring. One of the things we wanted to do is we added a jumper in the wiring for the Pioneer and the wiring for the VersaFlame, and there's a reason for this, which I'm going to show you in a second. So this jumper is factory installed. This jumper will come out when you're utilizing a Flame where you're doing priority, where you want to set the unit up on priority, and I'll show you how that's actually wired. But this will be a change we're making. It's starting July 1st on the Pioneer, which is new, and the manuals will reference that. This gives you an idea of how the unit would be set. This is a wiring diagram showing the VersaFlame set up with central zoning panel for zoning with DHW priority. And when the paddle switch makes, what's going to happen is this pump gets deactivated and the priority goes to the central heating, the DHW pump, which is connected to the brace plate inside of the VersaFlame. That's for zone valves. Pumps, what we're doing is we're now going into the ZRZC. We have a dry set of contacts on where the jumper was. So you'd remove the factory jumper from the line voltage to pin 9. You note there's 2 notes here. 1, relay closes when appliance process central heating demand. Okay, so when there's a central heating demand, we will power up these pumps, and we'll power up the pumps for the central heating loops. Since we don't need an individual pump off of our unit to circulate the water because there's no pressure drop through our system. The note 2 says the relay is open during a DHW priority, circulator pumps off, TT still closed. So what we're doing is we're shutting these pumps off. We're now giving priority to the pump circuit that's internally wired within the Versa Flame, and we're providing DHW priority. The functionality of that works the same with any of our low-mass boilers. There's a 30-minute limit, which I've never been in a job and never seen that ever go to that extent. But there's a 30-minute limit, and that would essentially then go back to the CH heating and then go back to DHW after another 30 minutes. Just some of the things within the manuals I want to point out. There is some different functionality on the status screens, and as far as the adjustments that you need to be pointed out when you're adjusting the temperatures, and you'll see that within the manual, because we give some notes here about the flame, and we still can connect up on the Pioneer with an indirect fired water heater. So if you look at the status menu, this kind of gives you an example. D3 in a Pioneer can actually, which is for the DHW, which is signifying the connection of an indirect sensor or one to a mechanical control. When you when you go into a Versa Flame, the D3 now represents on the display 1 if the flow switch is active, which means it's closed and the pump is running, and 0 if the flow switch is not active and open. D9 tells you that on a flame that the DHW pump module is 0 equals off and 1 equals on. So I just wanted to point some of those facts out. In your programming, we now have a low limit, and we have the ability to control the minimum temperature set point with the flame, because on the flame, normally our defaults are going to be what you see here, 180 degrees for the central heating, and then during the summer months, we have to maintain a certain temperature because we're relying on the storage in order to supply instantaneous domestic hot water. So we have a temperature set point, factory default, at 150. The customer can either raise this up or he can lower it down within these ranges. The Pioneer, you can do the same thing also. To activate those on either appliance, obviously on the Flame, we activate the low limit by setting number 48 to 1. And in the Pioneer, we turn it off because we don't need to set a minimum. But if your contractors want to have a minimum for some reason on the Pioneer, that's an additional feature that we've added.
There's a reason on the Pioneer that you want it active, and that's simply if you have a smaller indirect tank and you want to keep your Pioneer up to some specific temperature. So in the summertime, when your central heating shuts down, you can keep full tanks fairly warm. So, for example, if you want to keep your Pioneer at 110, so it doesn't have to go from room temperature all the way up to the full temperature required to heat up your indirect. That's the reason for that setting.
Okay. And then just some of the troubleshooting. In some of our installations that we did, our field installations, one job that I was involved in, they were supposed to have the system all bled and ready to go, but unfortunately they didn't. And one of the things that was happening is one of the gentlemen upstairs was bleeding one of the old cast iron radiators. And I lost pressure. I didn't know it on the gauge, and I was not pumping through the brace plate. And I found out that they had basically brought the pressure down to nothing. So you got to make sure you have your domestic pressure, you have all that purged, and you got to make sure that you have at least a minimum of 8 psi on the hydronic loop. to get the pump from being airlocked. If that does happen, there is some union connections on there. If you just crack them a little bit, you can bleed them real easy, or just raise your pressure and start and stop the pump manually through the plug. Another thing is you want to just check the flow switch. The flow switch is just a simple little plastic paddle that screws in. There's an arrow on it, so it indicates the direction of flow. So we put that in there just to make sure if there was a hot water problem that they're checking that. And then adjust the low limit setting higher if they're running out of hot water. So one of the things you can do in this is we've got flexibility to increase the ability to give you more hot water by just bringing that temperature up above the factory minimum set point of 150. Just to look at the device, we have this nice little shroud that gives it a nice aesthetic look. Here's our braze plate. On the domestic side, everything's already pre-piped. This is the hot water mixed outlet. We have our cold feed here with the flow switch, which is number 4. So that's the domestic side, which is on this side and this side. And then this is preset, this mixing valve, which is a TACO mixing valve, and it's ANSI rated 10, ASSE rated at 1017. That is preset to 119. And then we have our pump, our TACO pump, which is a 008 pump that is BFP connections. And then we have isolated flanges here, shutoffs, so you can isolate. You can't see it on this side, but we have isolation shutoffs on both sides, so you can isolate this whole circuit if you ever have to service this. And these are flexible lines here with teats. And this comes already pre-plumbed, pre-piped, ready to go, wired, and all the contractor has to do is purge the system to activate it. Okay. Questions? Any questions? We could open it up and see what questions the group has. Oh, is this questions ready?
Yeah.
Nicole. Okay.
Roger, I'll be sure to get that to you. I'll double check what happens with shipping for that.
Where did they start? Where did I see? Oh, okay. There is a piece of styrofoam that's shipped with the unit. The reason for that is
we actually went away from that piece of styrofoam. That was just for the initial build. Now the pipe clamp that was holding just after the pump actually holds the pump itself now. It's just a standard split pipe clamp that'll go right around the cartridge. So if you need to replace the cartridge for any reason, it's just 2 screws like your typical pipe clamp, but that'll avoid the turning and twisting during packaging or any vibration through its operation. So that's one thing we adjusted to the final production.
Okay. Will changes of software be available to units in the field for the PHR? Yes, that will be available. We are changing. The control modification is the same one that we did with the ModBus. So we'll have those controls available in part starting July 1st. We're working on the programming to update the programming for both products. That should be available within the next couple of weeks on the web to download, to upload those new programs. Yes, you can do that. You guys have I assume the whole system. Yes, the Jack, the system is all. What we're doing to check for leaks on the domestic module is we're doing a hydrogen check before it even gets connected to the tank. And then we do another check on the tank once it's on the production line when we're firing it. Any plans for ASME? At this point, no, because of some of the restrictions and the costs related to building a tank of that volume in an ASME construction. We don't feel would be competitive. Is unequal venting acceptable? Can combustion air be taken from inside the space? And is flexible venting usable? Yes, most definitely. You can draw room air from the space. The one thing you got to be careful of is you got to be careful, especially New England, Ken, that we don't have, with laundries and other things, we got to be careful of chlorides affecting the combustion system. And the flexible venting can definitely be used on both the Pioneer and the VersaFlame, and we highly recommend it. Are there more launch kits available? I did not receive, so John, we'll take care of that. I'm sure Nicole will contact you and get you whatever you need. Sold as a boiler or a water heater? ASME coming. The unit is certified. It's certified as a circulating water heater. I found out from the engineering department this morning that we do have Energy Star on the VersaFlame and the Pioneer, both the Canadian Energy Star and U.S. So that has been done, and we'll be updating that on the web as soon as we get those certificates. Can we chimney vent with sidewall outside air intake? You can use a chimney as long as you line it with the flexible material, like we did, Dave, in that job we did down in your area. And we can draw the air from the side or any portion of the building peripheral to draw our incoming air, or draw it from the living space itself. One thing about the Pioneer and the VersaFlame, when you're drawing air within the living spaces, be very conscious of the noise of the fan. There will be some noise, especially at high fire, if it's underneath someone's living space, a bedroom. Other areas, I would recommend that you vent that in another plane of the house and get it away from somebody's bedroom, because I've seen that be a problem. We answered about Energy Star. Can it be different distances? Yes, it can. Within the manual, we allow different planes and different distances. The vent has to be vertical, though. Horizontal venting has to be vented in the same plane. So in other words, if you're coming out it has to be on one side of the house. But in vertical, you can basically take your air anywhere around the peripheral of the house and vent vertically. Will there be a solar version of the VersaFlame? Annie's asking, will there be a solar version of the VersaFlame? At this point, we have no plans of doing that. The engineer's shaking his head, but everything's up for debate. So at this point, we're not. We do have the Versa Hydro for that, but because of the high temperatures you would need, it doesn't make a lot of sense. Water heating for condensing is not up and active on energy.
Star right now.
Oh, it is not. We just got our notification this morning, Ken. So that's something that should be coming within the next...
Probably next week or two, Ken.
Okay. So we did get notified verbally. We could just get the documents from them. What is the minimum...
That's been down for a month, Dave, just an FYI.
Say that again, Ken?
That Energy Star on the condensing water heaters listing, which includes all our Phoenixes, the Pioneer, and the Versa, has been down for a month. There's been nothing up on the site.
Okay. Okay, we'll take a look at that. I appreciate that. Thanks.
I'm assuming that means they want to go
What is the minimum GPM flow required for the flat plate heat exchanger to fire up? Paul, the minimum flow rate is 0.5 gallons per minute, which is pretty much standard with all tankless heaters. So the specification is in the manual, and the flow switch activates at 0.5 gallons per minute. Once you get over 8 gallons a minute, you will have some velocity noise through the valve, but it's not really that bad unless you're right next to the appliance. It was of a concern, but once you start getting over 8 gallons a minute, you're really going over the capacity of the system to transfer energy required to satisfy the demand.
Package will have it done so that they know when everyone's fine for it. And that they'll be charged.
Right. Well, again, guys, thank you very much for your time. These two products are we're very excited. I'm very excited about the VersaFlame. I think it's going to be a very competitive product. It's going to be really interesting to see how it's applied in the field. So we thank you for coming and look forward to favorable responses.
I will be posting this on the rep portion of the website as well, so if you have people that weren't able to attend, they'd be able to see that. I'm hoping to get it up tomorrow, if not the latest by the beginning of next week. Okay? Thank you guys for attending.
Thank you.
Well, recording. I want it to